Imagine holding, like, the ultimate smartphone.
Hmm.
It has incredible processing power, limitless physical flexibility, and it can actually rewrite its own software.
Right, but there's a fatal flaw.
Exactly. The battery permanently dies after 12 months. And if you put it near another phone, well, they literally try to destroy each other.
It's brilliant hardware ruined by a terrible operating system.
Yeah. So welcome to your custom deep dive. Today, we are looking at how synthetic biologists are proposing to rewrite that operating system by biologically uplifting octopuses.
Okay, let's unpack this because it sounds like pure science fiction,
Right.
but it relies on very real, immediate synthetic biology.
It really does. And to understand why scientists are targeting them, you have to look at their baseline. A wild octopus has about 500 million neurons.
Which is a lot.
It's huge. But unlike you or me, where everything is centralized in the brain, their intelligence is heavily distributed. Think of their nervous system like a massive corporation.
Okay, I like that analogy. All right, so the central brain is the CEO setting general goals, but the 8 arms are regional managers with the autonomy to make immediate local decisions.
Which perfectly explains how their arms can literally taste by touch. Like, their suckers have specialized chemotactile receptors that evaluate microscopic molecules without the CEO even getting involved.
Exactly. But that brilliant corporate structure collapses because of that short lifespan and, their solitary cannibalistic behavior. So this report proposes a massive genetic overhaul using targeted CRISPR.
Wow. Okay.
Yeah, and to get those genetic changes into the nervous system without triggering an immune response, they plan to use spherical nucleic acids, or SNAs.
Wait, why does wrapping DNA into a sphere suddenly trick the immune system?
Well, it comes down to shape and density. Biological immune systems are trained to attack linear strands of foreign genetic material.
Oh, so a straight line is a red flag.
Exactly. When you pack it tightly into a 3D sphere, the cellular guards simply don't recognize it as a threat. It slips right past the defenses.
That is wild.
Right. And once inside, they drop 3 distinct payloads. The first is inserting the human ARHGAP11B gene, which basically forces neural stem cells to keep multiplying.
So you're exponentially expanding their capacity for associative memory. I mean, imagine giving a wild animal the same complex spatial reasoning you use to navigate a new city.
It's incredible.
But memory doesn't mean much if that battery still dies after a year.
And that brings us to the optic gland. Octopuses have this biological suicide switch that triggers a rapid, fatal aging process the moment they reproduce.
Right, senescence.
Exactly.
Yeah.
By deleting the MPL2 gene in that gland, scientists can halt aging entirely. We're talking about granting them biological immortality.
Okay, so now we have immortal, hyper-intelligent creatures. But immortality is great until you realize they still want to eat each other. You basically just have immortal cannibals. How do you force a solitary creature to build a society?
By tweaking their SLC6A4 serotonin transport genes, if you suppress their natural aggression, they become prosocial.
So they can collaborate.
Right, they observe, and crucially, they pass down complex problem-solving strategies across generations. They actually build a culture.
Okay, but given the sheer scale of effort and money this would take, I'm assuming we aren't doing this just to create friendly underwater neighbors. We want them to do something our technology can't, right?
What's fascinating here is the massive infrastructural problem they could solve. Over 95% of global data flows through 1.4 million kilometers of deep-sea internet cables.
Which are incredibly fragile.
Very. And when they degrade, fixing them with heavily tethered robots is nearly impossible in that rocky, jagged underwater topography.
But a soft-bodied immortal octopus could just slither down there and use those regional manager arms to physically taste the degrading polymer sheathing in, like zero visibility.
And repair it with surgical precision. Or they can monitor fragile deep-sea mining zones. It's the ultimate biological tool for a trillion-dollar problem.
Okay, here's where it gets really interesting. If we give an organism human-level cognition, biological immortality, and a shared culture, aren't we just breeding hyper-intelligent, indentured laborers?
Well, from a purely utilitarian standpoint, they solve a logistical nightmare for human civilization. I mean, they would be incredibly effective.
But they cease to be biological machines at that point. They achieve undeniable personhood. You can't just hand a highly sentient immortal being a wrench and say, go fix the internet forever.
And that is the exact moral hazard the researchers validate. If we apply the Rall-Jean veil of ignorance...
You remind me, that's designing societal rules without knowing who you'll be.
Right, without knowing he'll be the human or the octopus. If we do that, we have to prevent systemic exploitation. To do that, the report argues we would need to establish two-way informed consent.
Wait, how do you negotiate a labor contract with an octopus?
By utilizing their dynamic, color-changing skin, their chromatophores could serve as a high-bandwidth visual language interface to actually negotiate tasks collaboratively.
Oh, wow. So what does this all mean? The vital lifelines of our modern internet rely on surprisingly fragile subsea networks, and the future of maintaining them might be entirely biological.
Yeah, we aren't just creating a marine workforce. We are redefining the physiological boundaries of intelligence itself.
Which leaves you with one final thought. If we successfully engineer these super-intelligent immortal beings with their own complex culture, what happens if they take one look at our messy underwater infrastructure problems and simply decide they don't want to work for us?